This is the moon, something we can all see nearly every night shining brightly in the sky. However, these lunar swirls are less obvious to the naked eye, and even scientists have long wondered what they were, despite having been discovered way back in the 1600s. However, a new study posits an explanation for one of these swirls specifically.
Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for some more science, space and tech news to share with you, and I came across this over at Science Alert. Yes, something hidden inside the moon could be behind its mysterious swirls, and scientists have a theory. Okay. Yes, that's interesting. That's the Rhina Gamma Lunar Swirl. Okay, well, let's find out and see what's going on here. The face of the moon is famous for its grey, pockmarked complexion, but did you know that if you turn a telescope to our planet's neighbouring satellite, you'll also see bright patches blemishing the surface? Now, well, didn't know that actually. Ever since these quirky features known as lunar swirls were first spotted way back in the 1600s, scientists have wondered where they came from. Now, to this day, light-coloured regions like that of the well-known Rhina Gamma swirl pictured below remain a mystery. That's really interesting. I didn't realise that. How many years have I looked at images of the moon and didn't know that? Well, learn something new every day, don't you? That's why I love, I'm not a scientist myself, just love, science, space and tech news, and astronomy is just an absolute fascination of mine. Yes, a new study from scientists at Stanford, Western and Washington University in St. Louis provide evidence of a new explanation. Now, unlike planet Earth, the moon no longer generates a global magnetic field to protect it from the sun's charged particles. It means that when solar winds collide with a lunar surface, they turn the rock darker over time due to chemical reactions. Are there any lunar geologists out there, or obviously these might have been formed by previous volcanic activity on the moon? If there are any astronomers or anything like that, please feel free to comment, because we'd love to hear from you. Yeah, love to hear your thoughts on this. Well, that said, some pockets on the moon appear to be protected by mini magnetic fields. Didn't think they had one. Didn't think the moon had one. Okay. So far, every light-shaded lunar swirl scientists have found coincides with one of these local magnetic fields, and yet not all rocks within them are reflective, nor do all magnetic fields on the moon contain swirls. So what on Earth, or rather on the moon, is going on? Now, some recent studies have explained the confusing results by arguing that micrometeorites' impact on the moon can kick up charged dust particles, and wherever these particles land, a local magnetic field barrier is created and solar winds are reflected. The researchers at Stanford and WUSL now dispute that hypothesis. They argue that some other forces magnetize the lunar swirls, deflecting the solar wind particles. Impacts could cause these types of magnetic anomalies, admits planetary scientist Michael Krozinski at WUSL. Now, we've got a little bit of a very short video here, give us a bit more background on these lunar swirls, and we'll check it out, and then we'll carry on the conversation when we come out the other side.
This is the moon, something we can all see nearly every night shining brightly in the sky. However, these lunar swirls are less obvious to the naked eye, and even scientists have long wondered what they were, despite having been discovered way back in the 1600s. However, a new study posits an explanation for one of these swirls specifically, called the Rhina Gamma swirl. The moon no longer has a central magnetic field and magnetosphere. However, researchers now say that it must have small localized magnetic fields, and that could have caused these swirls. They say that when the sun's rays hit the lunar surface, these mini magnetic fields protect some parts, but not others. This causes a chemical reaction over time, producing these iconic splotches of gray and, well, lighter gray. Still, the cause of these isolated magnetic fields is still a bit of a mystery. With the researchers writing, impacts could cause these types of magnetic anomalies, but there are some swirls where we're not sure how an impact could create that shape and that size of thing, with the study outlining how it could be that subsurface lava could have cooled slowly in a magnetic field, creating these magnetic anomalies on the surface.
Well, that was interesting, wasn't it? Yeah. Yeah. I love little snippets like that. They give you a bit more context. But there are some swirls where we're just not sure how an impact could create that shape and size of thing. Now, Krasinski suggests forces from beneath the crust could also be at work. Another theory is you have lavas underground cooling slowly in a magnetic field and creating the magnetic anomaly. Yes, there we go. This is, was it lunar swirls near the Fursov crater? I think it's going to be previous volcanic activity, because obviously the moon's volcanically dead now, but, yeah, let's find out more. Now, just below the surface of the moon, scientists have found radar evidence of what was once flowing molten rock. These underground rivers of cooled magma indicate a period of volcanic activity billions of years ago. Now, using a model of these magma cooling rates, Krasinski and his colleagues have examined how a titanium iron oxide mineral called ilmenite, abundant on the moon and commonly found in volcanic rock, could produce a magnetizing effect. Okay. Their experiments show that under the right conditions, the slow cooling of ilmenite can stimulate grains of magnetic iron and iron-nickel alloys within the moon's crust and upper mantle to produce a powerful magnetic field. Now, this effect, researchers conclude, could explain the strong magnetic regions associated with lunar swirl. Now, if you're going to make magnetic anomalies by the methods that we describe, then the underground magma needs to have high titanium, says Krasinski. We have seen hints of this reaction creating iron metal in lunar meteorites and in lunar samples from Apollo, but all of those samples are surface lava flows, and our study shows cooling underground should significantly enhance these metal-forming reactions. I didn't know that. Interesting. Yeah, what makes me wonder about volcanic activity on other moons in the solar system, whether it would be similar. Yeah. Any volcanologists, astrovolcanologists? Let us know. Love to hear from you. Now, much of what we know so far about the moon's localized magnetic fields is derived from orbiting spacecraft which can measure the effect using radar. But to really understand what's going on, we need to directly drill down into the lunar surface. Now, that's exactly why NASA is sending a rover to the Orion Gamma Swirl in 2025 as part of their lunar vertex mission. Now, in just a few more years, scientists may have the evidence they need to put this mystery to rest. The study was published in the Journal of Geophysical Research, Planets. Absolutely incredible. Yeah, as I say, been an astro nerd head ever since I was basically in the womb and my mother was watching Doctor Who. But sit back in the 60s. But yeah, just that's something I'd never really sort of thought about. And then when I think about it, I thought, some of the shots I've seen of the moon, they look more like craters of impact than craters of volcanic activity. And then you've got this thing thrown into the mix. Yeah, it really makes you think, doesn't it? Fascinating. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed the video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video because I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And as I also always say,
I'll be back.